Okay, in this video we're going to do a couple things. We're going to look at the domain and ranges of our piecewise functions that we saw previously. We're also going to talk about piecewise functions, something that it's a unique idea, but it's an important one as we move forward, especially as we get to calculus. So I'm going to just show you these here. The slides show them once again, then we're going to talk about the domain and range of each of them. So the quadratic, you remember, is the u. We've got the cubic here. Here's the reciprocal function, reciprocal squared. Now the square root, again, remember it was limited in order so that it would stay a function. Got the cube root here. Okay, now here's what we were really going for. We want to talk about the domain and range of each of these. Now, do you remember the domain would be if I were to take a ruler and I was just going up the x-axis, where am I going to hit something? Well, the constant function I'm going to hit everywhere. Now, if I were to do the range, what happens on the y? The only place I'm going to hit is whatever that value was. So if y is 3, then the only place I'm going to hit is at 3. This is just generic that you're just going to hit at that one point. Okay, so here's our identity function, which was y equals x, or f of x equals x, I should say, since it's a function. So as I move my ruler up and down along the x-axis, I'm hitting everywhere. As I move it up the y, which would be the range, I'm also hitting everywhere. All right, here's our absolute value function. So if my ruler was moving up the x-axis, I'm going to hit everywhere on this. Remember, it goes forever because of the arrows. But my range, if I was going up the y, is only going to start hitting at 0 and including 0, and it would go on forever. Now the quadratic is going to be the same as the absolute value. As I move up the y, I get the same range. Okay, here's the cubic. If you get the idea, see we're going for, if we move up the x, we're hitting everywhere. Move up the y, we're hitting everywhere. This one's a little odd because we never get to 0, 0. So if I'm moving up my x, I've got something everywhere, but I never get to 0. So I'm going to exclude it, pick it up again on the other side. Now the same for range. As I'm moving up the y-axis, I'm hitting everywhere, but I'm going to skip over 0, pick it up on the other side. Reciprocal square, same kind of concept. We're moving up everywhere on the x. We never get to 0, so we jump over it. And then the range, we don't hit anything till 0, but we don't include it because we never get there either. Square root picks it up at x is 0 and goes on forever. The range would do exactly the same thing. Cube root function, you're going to hit everywhere as you move along. All right, now this question is in here because it'd be asking this. If you were to look at these functions, find the domain and the range, I think this is in here because it's trying to say, if you had a question like this, what is the domain and range? That's what it's asking, I believe. Hold on, let me pause this for a second. Yeah, I actually added these, I think, for a previous textbook. I don't think it fits here. I'd have to see the questions we get, but I think this is asking something different here. So I'm going to skip over this thinking that I added that erroneously. Now let's get to what I really want to talk about here, which is piecewise functions. So the idea of a piecewise function is that it's more than one function and it breaks into different pieces over different domains. Let me see if I have an example here. So here would be an example of a piecewise function. It does different things. When n is greater than or equal to 10, it's a constant. But as we move from 0 to 10, we have a line. This is 5n. So a slope of up 5 over 1, up 5 over 1. So hold on, let me see what we got here. Okay, now the way I would graph this is, so we have a piecewise function. It's doing different things over different domains. So between 0 and 2, I have a constant function. When I'm greater than or equal to 2, I'm going to have this linear function. It's a little complicated, but it's just going to be a line. So let me show you the picture. So I'd have this. Now, here's my piecewise function, and yeah, the typical thing would be to ask you to graph it. So I'll mention this here. What I would do to graph this is I'm going to graph all of the endpoints. So I would graph when x is 0, I know it's g, but when x is 0, x is 2, and then greater than or equal to 2. Every endpoint that it gave you. Now, I would put 0 in, I would get 25. So right there. And now it didn't want to include that, so I would have put an open circle there to say we don't want that particular spot, but we start there. And at 2, we also get 25, so I would have given an open circle there as well. Sorry, this does not let me do circles. Okay. All right. Now, I want to find what also happens when it's allowed to be 2. So I'm going to find this endpoint 2. And I plug this in, and it turns out, once again, it's 25. So I would go back here, and I would be allowed to fill that in. Okay, and from that point, now that I have all the endpoints done, what I'm going to do is I'm going to graph between those points. So from 0 to 2, I'm this constant function, so I'm always 25. Now, well, it should be x, but when greater than or equal to 2, it's this function here, which is just a line. Let's tidy this up. So I've got 25 plus 10g minus 20, 10g plus 5. Plus, that's not a 5. There we go. Plus 5. 10g plus 5. That is terrible. I got to write that better. 10g plus 5. Okay, and it's confusing that it's g. We're going to just think of it as 10x plus 5. So I would be starting at this point here. That's now filled in. And what this is telling me is that I have a slope of up 10 over 1. Up 10 over 1. So I would then go up 10 over 1, up 10 over 1 to build the line from 2 on forever. Now let's do it again here. I hope I've got a couple of these. So we want to do all the endpoints. I'm going to do when x is 1, I'm going to do this top one. When x is 1, I get x squared is 1. So I get 1, 1. And it wants to include that, so I'm giving a filled in circle there. Okay? Now let's do this next one. I'm going to do every endpoint. So I've got 1 here. When it's 1, I get 3, but it's not allowed to include it. It's going to be an open circle. Oh, it's so hard to get this thing to do dots. Okay. Now I'm also going to do this endpoint. When I'm at 2, I also get 3. My goodness, I cannot get it to do this point. There we go. No, I still can't do it. Ugh. Okay, maybe that'll work. If not, okay, so I'm doing my endpoints here. I've marked 3 of them. Now let's do this last one. For x greater than 2, if I put 2 into this one, I get 2. Now it was an open circle there, okay, but I've already got a filled in circle there, so I'm good. Now I have all my endpoints. Now let's start building the rest. I have x squared when x is less than or equal to 1. Well, that started here, okay? And x squared is that shape that you should know. And I'm going to just stop it right there. Now, between this one and this one, so when these two endpoints, it was always 3. So I'm going to just connect them. And now here, when x is starting to be greater than 2, so going over this domain, that's a line. Y is x. That's the identity function. It's up 1 over 1. Up 1 over 1, up 1 over 1, and you would get that line like this. So I do all my endpoints, and then I put the pieces back from to connect it. So I have all my endpoints, what happened on the domain up to that first endpoint, what happened between the next endpoints, etc. So there it is, graphed nicely. They've got the dots. You see. Oh, did I get one of my endpoints wrong? Yeah, I did. I did get one of my endpoints wrong. So when I put 2 into here, I should have been at 2, 2. So my circle should have been starting here and going up. But they did it right here. So again, I've done my endpoints, put them all in the same one. I should have had this with an open circle there. I got that off. Okay, let's try one more of them. You can pause it if you want to try by yourself, but I'm going to go ahead and do my endpoints. So when x is -1, if I put -1 in here, I would get -1. So -1, -1, and it's an open circle because I'm not including it. Okay, the dot is probably not going to stay. I have so much trouble with that. Now from here, I'm going to put these endpoints in. When I'm -1, I'm always -2. And that is also an open circle. Okay, I've got to figure out how to let it do this. Okay. Now I'm going to put this endpoint in. The x is 4. At 4, when x is 4, I also have -2. Okay. Now we're going to do this endpoint. Put in a 4. Well, if you put 4 into the square root of x, you get 2. So I'm also at 4, 2. And that is also an open circle. Why does this not do this? Okay. All right, I have all my filled in circles. Now, when we go from the point -1, -1, we had our cubic there. So a cubic looks like this. It would have kept going and turned upright, but we stopped at that point right there. Now between these two endpoints, -1 and 4, I'm always -2. And from 4 on, I'm always, well, I'm the square root function. From here on, I'm a square root. And I don't need you to get these perfectly, like they have to match. If you know the basic shape, that's what you need. And this is our piecewise function.